Hi guys, how we doing? Welcome back to another video. So I've just figured out how to get an ESP32 talking to a PLC, and not this time not over Modbus but using S7 comms. So I just thought I'd share it with you. All this code is available on my GitHub. So just go on my GitHub, find ESP32 PLC comms, and then just make sure you read through the instructions. And it's not complicated. It's just like there's a few steps you got to amend some libraries and stuff. So I'll just show you how it works first of all. So I've got some code here. This is running on the ESP32, and essentially all it's doing is it's looking at it connects to the PLC using so there's a library called Settimino over here, which I've got this library bundled on in a zip file on my GitHub, so you can download that there just in case this SourceForge link doesn't work. Essentially the way that it works is, if you know anything about Snap7 Python library, there's a Snap7 Python library which is used to communicate over S7 comms with a Siemens PLC. And if you don't know what that is, then the older PLCs on Siemens, they used to communicate using something called put-get, or they were able to communicate using put-get. You can still use this. So you go into your Siemens PLC, go to your properties, and then come down to protection and security, and then you just have to tick permit access with put-get communication. And now this allows essentially any device to read and write to your PLC's tags. So what I'm doing here is I've got I give the ESP32 my PLC IP address. I've got some information here about how to set up your database, so I'll show you. Here I tell the ESP32 what addresses it needs to go and ask the PLC for, so that this is using DB1, and then you got DB1, and you just have to turn on. So one thing you have to know is that on the data block you want to use, it needs to be an unoptimized data block. So on properties, might be teaching you to suck eggs here, so sorry if this is basic. So protection, nope, attributes, and then just make sure it's not optimized block access. That then gives you an offset value for each IO point. So here, for example, I've got my offset 32.0, and if we scroll down, where can I find it? So okay, there you go, 32. So it's not 0.0. So this analog input scaled, I've told the ESP32 to go and get this value here at dB1 and then offset 32, and then now, so you can see there I've got 6.3 on my analog input as a scaled value there. And then if I now look on the serial monitor, this prints all the code here. So it tells me, like, you know, I put a little header about me, my Wi-Fi that's connected, what PLC it's connected to, what port, and then now here you can see analog input 6.3. So if I just turn on auto scroll, it's now printing, the serial monitor is just printing every whatever second all the PLC tags that I wanted to look at. And you can look at tons of tags. I've just selected here just like my main tags, but I've done way more than this in the past. So you can see I got 6.3 here. I'm now just going to go and just change the voltage. So I crank that up to 8.4 now. And you can see that I've got 8.4 being read pretty much in real time. So I'm just rolling it down now. I'm at 1.2 volts on my analog input, 1.2. And it's just instantly responsive. 3.6 now. Crank it up more, 5 volts. It's very good, honestly. It's insane how responsive this comms layer is. So I think I prefer this way of communicating with a PLC using the S7 comms than to Modbus and to write into addresses. This means that, like, there's no real setup on my PLC code can stay exactly as it is, and then now I can just access and read everything. So yeah, all you have to do, if you want to use this, grab this code, read the instructions a little bit, and then just change all your addresses here, and you should be good to go. Yeah, I think that's it from me. Cool. So like I said, just go read the GitHub, have a look, and enjoy.